And after country comes everyone that makes the Agribusiness and Countryside Development Foundation possible. We give all of our gratitude for the generous support from our special partner institutions, senior special partner institutions, corporate members, and individual members, all of whom without you would not be able to bring you our sessions every week and do what we do for rural development through agribusiness and job creation here in the Philippines. Thank you so much to all of our members and our donors for allowing us to bring you today's session. And once again, I am the president of the Agribusiness and Countryside Development Foundation in partnership with the Management Association of the Philippines. It's great to see everybody here, this morning. Again, I apologize for the change in the schedule because our speakers for this morning come from two very different parts of the world. Once again, I'm joined by Engineer Ramesh Nagasamudram, coming to us from Bengaluru in India, and Tom Boot from Myriota in Australia. Tom, good morning. Good afternoon, actually. I'm sorry we're eating into your lunch break. We're really glad that you can join us today.
Yeah, really glad I can join, and thank you so much for the invite. Really appreciate the opportunity.
No problem. Okay. So unfortunately, our chairman, Ernie Ordonez, is not here today, so I will be introducing our speaker for this morning. So our speaker for this morning is an experienced technology professional who has worked in the IT and telecommunications industry for over 13 years. He has spent the last 5 years focusing on satellite communications at Myriota for an Australian-based Internet of Things or IoT satellite connectivity provider. He has extensive knowledge on how satellite connectivity and the Internet of Things or IoT can be used to solve the challenges faced in the agriculture industry. Monitoring and management of greenhouse environmental conditions can be improved by many different innovative technologies, and Tom is able to offer a consultative and educated opinion, which is based on his experience across implementing multiple software and hardware solutions in the water industry and hopefully in the agriculture industry here in the Philippines as well. So may I please ask the members of our audience to please join me in welcoming our speaker for this morning, Tom Boot from Myriota. Tom, good morning, and please take it away. Yep, we've got your presentation.
So good morning, good afternoon. Sorry about that. I was just making sure I have my screen shared and turning myself off mute as well. So I really appreciate the introduction there. Definitely relevant to the agriculture industry. We do have a lot of crossover between the water and agriculture industry, and really looking forward to speaking today and how IoT satellite connectivity relates within the agriculture industry, specifically to the Philippines, and then some applications that we've worked on throughout Southeast Asia. Ramesh has organised this, but as you mentioned, I've been in IT and telecommunications for the last 13 years. Over the last 5 years, more concentrated on satellite connectivity specifically and working with Myriota. We have a low Earth orbit satellite network, and we've established that over the last nearly 10 years of operating as a business. And then over the last year, we've worked with Ramesh, who's helping us throughout Southeast Asia as well. So I'll let Ramesh give a bit of an introduction, and he'll be helping along with the presentation as well.
Thank you, Tom. I'm based. Thank you, Julius. I'm based out of Bangalore, in India, and I've been in the satellite industry now for well over 20 years. Generally addressing and delivering solutions for varied sectors and industries, mostly in the Asian markets. And thank you very much to ABCD Foundation, and thank you, Julius, in particular, for inviting us for this event. We hope that at the end of this presentation, we might be able to give you an overview about how the industries have evolved and how satellite and in specific Myriota can address some of the challenges that the agro industry faces in Philippines. So over to you, Tom, and yeah.
Okay, thanks, Ramesh. So Moving along, I'll just go through a quick agenda. Today we're going to talk about how Myriota provides reliable connectivity for the Philippines market. We'll be focusing on the agriculture industry specifically. We'll provide an introduction to Myriota and how our technology is specifically suited to the Internet of Things. Ramesh will then provide an overview of IoT in the agriculture industry for the Philippines market. We'll have some time to answer any questions and then recap on the information covered halfway through. And we'll then take a look at how Myriota has solved some challenges related to water supply in the ag industry and applications, some case studies, and then progress on to how to deploy the devices and next steps. To begin, it's important to highlight that only 10% of the Earth's surface can be monitored with existing communications technologies today, and a large 90% of the Earth's surface is not covered by existing terrestrial networks. Depending on the technology deployed, you may also have to install your own ground infrastructure and network equipment, all while ensuring power to these systems. All of this creates a significant challenge which is expensive and time-consuming to solve. With limited global coverage, this makes it extremely challenging to monitor and manage many key applications. For example, many usable freshwater sources are located in remote areas and outside of terrestrial range. They are off the grid and they become a significant challenge to monitor. In the forestry sector, for example, we have 31% of the earth covered in trees, which is diminishing with deforestation. And as a result, we're seeing deterioration of rainforests. Global connectivity and access to data can ensure our forests and ecosystems are monitored and they remain intact. There are also many challenges to consider in relation to climate change, monitoring livestock on farms, and keeping track of assets on farms when they're out of range. So imagine if solving these connectivity challenges was easy and it was possible through a satellite-connected IoT solution that was able to track assets anywhere on Earth at any time. An easy-to-install monitoring solution that just works out of the box would provide a way to manage many of the challenges we face now and into the future. And that's where Myriota comes in. And Myriota has been established as a company since 2015, and our technology has existed since 2011. So we tested it really early on with existing satellites that were in orbit. We specifically focus on connectivity for the Internet of Things, and this means we can obtain information from anything on Earth by using technology that's ultra low cost and consumes very little power. As an example of this, we have devices in the field today that can last for over 5 years using only 2 AA batteries. And our service also costs less than any other satellite connectivity option in the market today. We have some significant investors and partners that have helped make this happen, and they're all listed on this slide. We have global coverage with a reliable and well-established satellite network. We focus on some specific key verticals that are well suited to satellite connectivity. The agriculture and water industries are where many of our deployments operate, and our devices mainly operate in remote areas. We have thousands of devices deployed in the industries highlighted at the bottom right of this slide. This includes defense, where we're building the Internet of Military Things in Australia, utilities, which covers electricity and water meters, logistics for vehicle and container monitoring, and monitoring environmental and weather conditions. Throughout Southeast Asia, we've started in Malaysia and Indonesia, and we're focusing on the Philippines now. And I want to get into some of the use cases that we're covering and some of the applications that we've worked on so far. So here's a photo of our team after one of our successful satellite launches. We're based in Adelaide in South Australia, and also another photo after a recent event that we had. So our team members are spread out throughout the globe, not just in Adelaide. They're in South America, North America, Asia Pacific, Europe, and we work with companies like Ramesh at Any Aerospace as well. With nearly 100 people on the team covering engineering, satellite operations, network maintenance, and technical support. So how does the Myriota network operate? So the images for each industry show how solutions can be versatile and how they can be adaptable to many different applications. We work with many different areas and industries and operate on either mobile assets such as vehicles or boats, or stationary assets such as water tanks or pumps on farms. The dotted lines leading from each asset to the satellites illustrate that our satellite connectivity provides two-way comms. Two-way communications allows us to transmit network updates, configuration, and device commands. This means our devices are updated as soon as we have new satellites added to the network, and this significantly improves our latency and the ability to constantly update the network and have new satellites on board. Our modules work by staying in sleep mode until the satellites are overhead, so they maintain all of the network information on board and all of the satellite locations on board. And we use a store and forward protocol to set up when the messages are scheduled, and this queues all of the data on the module until the satellites are within range. So then once the satellites are visible, our modules wake up to start transmitting messages across. And this is how we achieve such low power consumption figures. Our satellites can also cover a radius of 5,000 kilometers, which makes it extremely easy to have line of sight to collect messages when they're sent. Once messages are received by satellites, we transmit data down to our network of ground stations, and the data is then exported out via REST API to be visualized by the end user. So currently terrestrial networks don't cover 90% of the Earth, as I mentioned. Myriota's technology solves this by providing direct orbit connectivity from anywhere on Earth. There are a number of other challenges for IoT connectivity that need to be considered. Cyber attacks and hacking is a constant threat, and remote IoT devices should be just as secure as devices in the office. It takes a long time to integrate devices into visualization and analytical tools with existing connectivity options. Higher power demands for devices mean much larger batteries or solar is required at times. And depending on the technology, you may have to install your own infrastructure or network equipment while also ensuring power to these systems. All of these problems can make analyzing a return on investment extremely difficult. So we'll look at how we solve some of these challenges and then get into some more relevant examples for agriculture within Southeast Asia. So Myriota connectivity provides coverage anywhere regardless of where you need to collect the data. This could be weather and rainfall, harvester or tractor location, or water pumps and tanks used for irrigation on farms. With built-in end-to-end encryption from the module to the endpoint destination, you can be sure that the devices operating on a network are safe. Our data is exported out via REST API, and this makes integration into any visualization tool extremely easy. And the design of our network and our patents allows us to operate on low power frequencies, which allows the end user to achieve longer battery life. And even using 2 standard AA batteries, you can achieve over 5 years of life on a device, which means you can simply buy the batteries off the shelf and use them to deploy the device anywhere on Earth. We transmit direct to orbit, which means no gateways are required on the ground, and it's as easy as deploying the device. All of this means a very affordable solution that's easy to deploy and can run for a significant amount of time. So I'll now pass over to Ramesh, who'll explain more about IoT adoption for the agriculture industry in the Philippines. We'll then share some examples of applications we've worked on in the agriculture industry and talk about how they're applicable to the Philippines market. So I'll hand over to you, Ramesh, and
Thank you.
feel free to jump across and hand back to me when you're ready.
Yes. So over the next few slides, I intend to present or give an overview of the Philippine agro market and how I believe that you can adapt IoT and satellite-based IoT to improve output and efficiency. Incidentally, I was in conversation with a colleague of mine, and he specifically reminded me about the role of the Philippines in the 60s to address the world hunger situation. I was told that there was the Rice Institute, which was set up in Philippines, and it really served to a large part of the population in Asia and saved over 1 million lives. So there has been a history about the role of Philippines in trying to address the agro industry, not just limiting itself to the Philippine market, but its contribution to the Asian market in whole as such. So that was one point I thought I should bring it up. As with any agrarian economy, I think the role of agriculture is very important for the country's economy. But at the same time, as we can see from these slides, that there are indeed a number of such challenges that Philippines in particular faces. One of them being the small farm sizes, very, very typical of Asian farmer holdings. And also the second challenge is the limited infrastructure that is available, and how does one get over these? Even if there is a better infrastructure, is that meaningful, and is it financially worth the effort to invest? Over the next few slides, as both Tom and I run through, we will present solutions that come out from Myriota, which are simple, easy to deploy, and then provide you a greater understanding. Well, talking about agriculture in general, over the last many years, there has been a great adaptation of satellite for smart agriculture worldwide. Specifically, the use of satellite in some of the Asian neighborhoods has been well demonstrated, and they have done well in using satellite for agriculture. So these two slides talk about how satellite has been used by either the application or by the system use. I'd like to specifically talk about the slide on the right, which mentions about the use of satellite by the application. Two very key applications stand out. One is precision farming, and the other is smart greenhouses. These two, I believe, over the next 5 to 7 years, as per this analysis, would see significant role by satellite in these two areas. Yeah, Tom. It's not that Philippines is new to IoT as a more mode of technology adaptation. There has been a significant role by IoT over the last many years, predominantly in industry IoT, smart city deployment, healthcare. In all these areas, there has been a huge adaptation of IoT, as quite evident by this graph. However, there's one particular sector that has been very slow to adapt, this being the agriculture. There are 2 or 3 primary reasons why agriculture has been a little slow in adapting to technology. One being the very limited availability of connectivity. I was also discussing with Julius the other day, and it's saying it's that beyond a certain prime cities and large population areas, mobile connectivity becomes a big challenge. The second is that there are technologies which can cover, but they are very, very expensive. We are hoping that at the end of this conversation, and together both Myriota and ABCD Foundation can address these issues and maybe come up with some interesting solutions to get the agro industry in Philippines also adopted this market. Right, Tom? Mm-hmm. There's something which is, I've been doing a little bit of a research for today's conversation and today's presentation. Then I noticed that there has been a lot of initiatives by your government in trying to adapt to new technologies for agriculture. Incidentally, the Department of Science and Technology, DOST, and DOST is a Hindi word for friend. So that's something that I noticed that it's a good terminology to use. DOST has been playing a very crucial role in promoting smart agriculture solutions. I believe that some of the key areas where your government is taking initiative is towards making greenhouses smarter. On that count, at Myriota, we might have some very specific solutions which can address and bring in smartness or better connectivity and communication between the greenhouses and your central locations. So that's something that I thought I'll talk about. And then Tom, yeah. There are quite a number of use cases that we have successfully been able to demonstrate. These use cases talk, as Tom would mention, a variety of sectors, right from addressing the challenges like deforestation or addressing the big challenge that we all face is water and how do we do water level management. Tom will run through all of these in specific, and maybe at the end of that presentation, we would open up for question and answers. So, Tom, over to you, and thank you very much.
Thanks, Ramesh. As you mentioned, there are many different examples, and this is just a selection of 3 to highlight that we've worked on in Southeast Asia. So animal tracking, we're tracking elephants in Malaysia for Defence University there. Deforestation is another one we've worked on. You can see an example deployment there of one of our developer toolkits collecting information in a forest. And then tank level monitoring is another example. This is one that's been quite popular globally with a whole range of different tanks. It could be fuels or fertilizer or water. And we're able to put a level sensor in the tank and then record that and send the information back via a satellite network. So really, the agriculture industry accounts for a staggering 70% of global water usage. Myriota devices have been deployed in trials for monitoring all sorts of tank levels, and we're working on many different other applications as well in the ag industry. So let's get into more specific diagrams that can illustrate how these would operate. So illegal logging and deforestation is responsible for around 10% of global warming emissions alone. And illegal logging means forest products being harvested, transported, and processed or bought and sold in violation of national or international laws. And initiatives are taken by companies we work with to prevent this happening. This is currently being achieved by monitoring a forest in northern Malaysia. The sensors being used to monitor the environmental conditions, sound, and activities in the area so that they can get accurate data and information and transmit that back via satellite. And you can see the devices deployed within the forest and would be mounted high up so that you can get the signal through and that it's got clear line of sight. And we've got all sorts of different sensors deployed alongside that. So it might be detecting the soil, the humidity and temperature, or simply the sound and the activity and what's happening at the time to it's able to track the whole environment and what's going on. UPNM, as I mentioned, or the Defence University in Malaysia, has been able to work with wildlife sanctuary there to track elephants. The tracking data then helps to build knowledge of elephant ranging behaviour and an increasingly crowded environment. This information is really key to preserving the habitat and the corridors that link areas to both the elephants and people who live in those remote villages. And plantation monitoring is another use case. It's quite common. It's come up quite a bit in the different events and different customers we've spoken to. So we've had quite a bit of demand around things like durian, vanilla, and also pineapple plantations. And this varies quite a bit, but it all comes back to tracking soil health, soil quality, and water information and water data throughout that environment. So this tracking data on the environment and some other examples could be temperature or humidity or movement. All those different data points can then be transmitted back, and you can see how the diagram operates and how it works. We've got the satellite there and an arrow leading up to a satellite, so you can see the uplink of 20 byte packets of data coming from the plantation, and we can transmit those up to 50 times per day. But you can also see there's a downlink coming back to say, okay, if I need to then update the device on the ground, if you need to send a command and control message, or tell the device to switch a water pump on or off, or take some sort of action, you're then able to transmit that back down. The arrow leading from the satellite to the cloud illustrates that the data is then sent back to a ground station, and then it's exported out to a visualization tool. So a very clear example with those 3 and how we can diversify, how we can integrate our devices with different sensors. One of the devices with me. So this device here is an example of what we'd have deployed You can see it's a really small unit, about the size of my hand. It's got an antenna up the top. You can see that. So that's just handles the transmission up and down. Then you might have a sensor that comes at the bottom of that. So that might go into a tank, or in this case, it would go down to the soil. It could be generally we work with about 30 or 60 centimeter probes that would go down. They can go longer than that. And then they pick up all those different types of information around the soil and water quality. So moving on onto the next slide, this is some more general information about Myriota. So overall at Myriota, our mission is to realize the full potential of global connectivity using direct-to-satellite sensing solutions that work anywhere on Earth. We provide solutions that get past the barriers faced when trying to monitor and manage key assets in remote areas. So from groundwater, tank and trough, and river monitoring, through to pump or environmental monitoring on farms, our connectivity for IoT provides low cost, low power, and secure network options anywhere on Earth, anywhere on the Earth's surface via low Earth orbit satellites that orbit about 500 to 600 kilometers up. Our direct-to-satellite technology means no ground infrastructure. You're simply deploying the device and that transmits direct to orbit. And the design of our network and our patents means much less power is required. So as I mentioned, 2 AA's will be able to get 120 times the battery life of alternatives in the market. We can use any off-the-shelf option or connect with solar or have an external power source, which enables us to achieve that significantly longer battery life than any other alternative, which is key in a remote area because you don't have to revisit the site for maintenance. This is a quick comparison to other connectivity options. Our satellite connectivity can provide a significantly longer battery life. The network is self-optimizing, so we're always updating devices in the ground as we add new satellites. We're partnered with many different satellite providers. We've also launched our own satellites. So we've got many different satellites in orbit that provide significant redundancy for the network. We're always able to support that and provide a reliable service. And we've also got a support team around the world to then back up this service and make sure that the maintenance required is kept to a minimum and the devices are always operating and staying reliable on the ground and returning data. Myriota-enabled solutions can operate off one product SKU, so there's no need to operate off different SIM cards in each region. We have one chip that operates anywhere. There's no restriction on different countries. We can simply deploy a device anywhere on Earth that operates anywhere. We can assist in operating and with existing hardware solutions we can use today, and our team of engineers can assist with design services to speed up integration of satellite connectivity into your product. And with built-in encryption from the device all the way through to the end user, you can be sure that devices on our network are safe. And our solution is built around keeping the data safe and secure. And that's why we do quite a bit of work with defense and government. There are many options to get started developing and testing on the Myriota network. Firstly, it's about validating your solution, and one of our developer toolkits in the first image here can be used to test your application on the Myriota network. You can code your own applications onto one of these devices prior to making your own custom device. And the image above design in the second box shows the Myriota module. These chips can be integrated into a custom built device, or if you prefer to start with something out of the box, we have a device called Sense and Locate, and we're releasing another device soon, which again can be used out of the box. And these devices are pictured next to the module on that second window with under design. So we have some custom devices. We've got options that operate today if you want to run a small trial with only a few units. And once these are deployed, the data is exported out via REST API, so you can access it with any visualization tool, and we can help you to set up those reports and dashboards. So from here, I thought it would be good to have a break and just see if anyone has any questions or if we can recap any of the information that's been provided, and then I can continue on into some more specific case studies from here.
Okay, so I think maybe we can entertain one question from the audience before we continue. There will be another Q&A after this one, which I think will be a bit more.
Okay.
Yeah, so maybe if there's a question from the audience, we have enough time to entertain one question before we move on to case studies. I see Jello has unmuted. Jello, do you have
Okay, actually it's, oh wait, ask me to start my video. Sorry.
There we go.
Hello. Okay, I don't see the videos actually. I can't see myself. Anyway, the question would be more of, since you said that the sensors are on sleep mode while the satellite is not overhead, how often do the satellites usually orbit over the sensor? Because understandably so, there would be some delays before the platforms can get access to the data via API. So how often is that? How long can those delays be normally?
Yeah, so you can see all of our satellite pastimes in the device manager portal. You can actually register for our device manager through the website as well. It has all the pastimes, so you know exactly when to deploy the unit and when you're going to get the most success from deploying it. They can range depending on the day, but we generally see about 15 to 20 passes, and that allows us to get a median of around 3 hours for our latency. It can be much shorter than that. It can be a bit longer. That would all depend on the latency between getting the data to the satellite and how long it takes to go over a ground station and send that data back down. So there's a few things to factor in when thinking about the latency, but we're very transparent about the satellite pastimes, and we're happy to share that information so you know what's going to work best for your devices and for what you're looking to achieve.
All right, thank you for answering that question.
Thank you very much for the question, Jello. That was a pretty quick one. Maybe we can do one more from our audience.
I have another question.
Okay, sure. Okay, sure,
Okay,
Jello.
the data is stored in Myriota's database. It's a very straightforward question.
Yeah, that's another good one. We don't store any of the information. We simply pass it through to our satellite, back down to the ground station, and it's exported out from there. So that's a
Okay.
really key point of our service. It's encrypted until it arrives with the end user, which makes the security around the information we're processing so good, because we don't actually know the messages that are being sent, and it's only available to that end user and then to the person that's sending that information as well.
Okay, so Myriota is based in communication, and the end users provide their own databases for storing there.
Yeah, exactly.
Okay, thank you.
All right, thanks very much. Again, super fast question, so I think we can entertain one more. Oscar, just one more question. Oscar, come in.
Yes. What infrastructure would be missing that you find in the Philippines? Is it internet?
Okay, yeah.
Is it the presence or absence of internet connectivity?
Yeah, thanks, Oscar. Good question. We actually operate our own proprietary satellite network. So you wouldn't need any internet connectivity. The data would be operating off our satellites. It's a low Earth orbit network that's independent of any internet service, simply operating off our own network.
Let's say we're a company interested to utilize your technology, your devices, and how could we say we would do a physically, we would accompany you physically to our location, and then well, say try it out and fly out your device or something. Would that be the way to do it?
We can provide the devices to a solution provider within the area, and they can help with the installation and help with implementing the device. So we would normally provide the hardware to a professional that can install that unit with you and visit the site and then assist with the deployment. So if you think of us as more of the connectivity provider that would work with a network of solution providers to then assist with the installation in that local area.
In other words, I'm asking, would you have already surveyed the Philippines? Our provinces, our far-flung areas. You think your system would be applicable or workable? Do you have already something like that done?
Oscar, I think you broke up on us a little bit. Are you asking about applicability of the technology to the Philippines? Is that
Yeah, asking, would Myriota have they already surveyed or given by some government agency the possible areas in the Philippines where they have this internet availability?
Yeah, I think I've got enough to answer the question. We have coverage over the whole area now, over all of the Philippines. So we'd be able to transmit up to 1 kilobyte of data per day. So we've validated the service and we know that we can transmit up to that 1 kilobyte each day. We just need clear SkyView for the device, and that will be able to transmit from any location in the Philippines.
Can we have your
Oscar, I'll interrupt because we still have a bit to go with the presentation. So if it would be okay with you to reserve your follow-up questions for this Q&A that will come after this one. I'm really sorry because we do have a bit we still have a bit to get through, especially when it comes to case studies, which I think will also be very interesting to the audience. Sorry to cut you off there, Oscar. But yeah, I think. Oh, do we still have you? Have we lost you, Oscar? Hello. Okay, Oscar's a bit frozen, so apologies to the audience. So we took 5 questions there. But anyway, I'll smooth things over a little bit later. We have another Q&A coming up, so I'll just ask for. Yeah, okay, we lost Oscar. So let's just continue with the presentation first, and then we'll tackle the questions in our upcoming informal session. Tom, Ramesh, back to you.
Yep.
No problem. All right, thanks so much for that, Julius, and I appreciate Oscar's questions. Hopefully we'll be able to recap on those at the end. So as I mentioned earlier, we have a diverse range of devices that have been developed by our partner network. These are all highlighted on our website, and all of the different applications they cover are highlighted and explained in detail as well. So if you go to our website, you'll be able to see all of these examples. They're all ready to install and suitable for many different applications, and you can find more information on partner page, or you'll see there's a case studies page, and they're really going into detail and provide some excellent information if you're interested. So getting a bit more specific into the water industry and the challenges of how this relates to agriculture, because there's quite a bit of crossover there. We've monitored many different water tanks and water pumps, troughs, water quality in soil on farms, and I've noticed quite a bit of crossover. So I want to explain that in a bit more detail. IoT communications technology is really changing the way we protect our most critical resource, which is water. And despite it all being around us, usable fresh water is incredibly scarce globally, and often in remote locations that fall outside of terrestrial connectivity, it can be hard to get a connection to then return some of the information you need. And we've got some images here that are showing some of the devices. We've got a rain gauge, which we've got available, a water meter monitoring device, tank monitoring, and pumps and flow meters, which are all based around that water. And you can see how that might capture information within a farm or throughout a remote landscape. So we have location monitoring, which is one of the things we track on mobile assets like emergency pumps on mobile water tanks. providing data for position on maps, location reports, or insights into usage and optimization of resources. You can receive non-critical notifications if assets are moved from their intended location, which helps reduce theft of temporary pumps or remote equipment on site. And our network and growing partner solutions are applicable to the entire water system, monitoring the entire on-farm system for that matter, for tank and dam levels, pump efficiency, rainfall, rain gauge and water tracking, water meters, and groundwater on site as well. Looking at the challenges specific to water, there are some key points. So many usable freshwater sources are located in remote areas outside the terrestrial range. They're off-grid and they become a significant challenge to monitor. As reported by UNICEF, by 2025, 50% of the global population will be living in areas facing water scarcity. As published by National Geographic, only 3% of water is freshwater, and most of that 3% is locked in glaciers or underground, meaning 1% can be used for drinking. And agriculture uses 70% of the world's accessible freshwater, but some 60% of this is wasted due to leaky irrigation or inefficient application methods, as well as cultivation of crops that are often too thirsty for the environment in which they're grown. And with the tight margins around this, it means every drop of lost water can count. Highlighting many of the challenges for facing ag and water industry, we can help you focus the solutions that both protect this resource and create substantial business opportunities. And as a capital-intensive industry, water management must pay close attention to the utilisation of water and the performance of equipment that are relied on farm and when tracking water usage, particularly for irrigation systems. Productivity and monitoring assets shouldn't diminish outside of the city limits, and satellite IoT presents an opportunity for massive economic growth and resource sustainability. So based on a combination of anywhere connectivity, sensors, and AI technologies, water utility operators and farmers and companies have the ability to achieve less waste, less consumption, and improve management of resources and water on their farms. So I'll now run through two case studies regarding companies we've worked with in the agriculture industry. Firstly, with Grundfos. So Grundfos is the largest pump manufacturer in the world, meaning their pumps are in many diverse and remote locations around the globe. We've started working with them in Australia and then expanded out into the US and Europe, and now we've got global deployments with a product that's called Solar Connect. So Grundfos Solar Connect, if you're interested to look that up. We monitor tanks and pumps on site. So we include a mobile app with that for data visualization. And we have durable sensors that are built to withstand some of the most harsh and remote environments that water is found and used in. Solar Connect devices are simple plug-and-play products that close the data loop with round-the-clock remote monitoring of water infrastructure. And through our connectivity, we can provide end-to-end insight of pump status, pump volume, and tank level, which is all carried out remotely. The devices receive data and use edge computing to compress the information down and then send that data from any location. This example here is more within Australia, in South Australia, but it's relevant to anywhere in the world. You can see that the devices are out in remote locations and they're just transmitting direct orbit without the need for additional infrastructure. The South Australian Department for Environment and Water are utilising satellite data connectivity to monitor groundwater levels. So they have a sensor running underground and then the device sitting on the surface to transmit that information. In the past, monitoring groundwater usage required a manual read of each water meter, and it was a very resource-intensive task given the size and remoteness of this part of Australia. Let's take a look at some of the pain points that are encountered when monitoring groundwater and how Myriota's satellite connectivity provided the required solution. So South Australia is very large, remote, and dry. With our global coverage, it meant that no site was too remote, and a single solution could be used for all sites. Cost, complexity, and scalability of terrestrial IoT solutions like cell towers or gateways presented another challenge. By working with us, the Department for Environment and Water has now automated satellite IoT options that are easy to install, cost-effective, and reliable, and they can withstand the most harsh environments. To add to this, new legislation means that particular customer needs more accurate and readily available trend data on groundwater usage, and we're able to provide that through custom dashboards. So there are many options to get started developing and testing on the Myriota network. On the left-hand side is one of our developer toolkits. This is a finished device, that can be used to code your own application and add sensors to. You can test the Myriota network out before building your own custom device. And they come with 2 modules, so really easy to test out and decide whether you want to integrate the modules into something more custom. The unit in the middle of this slide is our sense and locate device, and these can be used to simply code your own firmware and then plug in a sensor. These are outside of obviously the many custom partner products we have. So we've got a range of different options. We can either help with something you can use to test, or a module that can be integrated into your own device if you want to build your own, or otherwise we can suggest a partner product to deploy. We've got a device and network management portal, which allows the activation and monitoring of devices in the field. And as previously mentioned, your data is available via REST APIs, which makes them easy to view on your preferred visualization platform. But we have some instructions on how to use 2 examples, Tago.io or Eagle.io, and I can send you a link to our developer resources page, which then explains that in a bit more detail and goes into detail about how you would integrate our hardware with visualization options. So there are several pathways to market. You can decide to do it yourself using the documentation and our Myriota modules, or you can fully integrate the module into your design to meet your specific customer needs. Another pathway is to utilize our existing hardware like the sense and locate device by simply adding a sensor and modifying the firmware. Another one would be that we offer design services. So we can build the device from scratch, we can help with the integration of the sensor, or we can assist with writing the firmware. Or otherwise we can pass you on to a reseller or a local solution provider like Oscar talked about earlier to help install and more monitor that device locally and help with the visualization aspect as well. So there's many companies that might not have the engineering experience to build a device, and that's where we can help with the design services. So you simply tell us what you need and we can provide a quote to build that. And we can help with different aspects of that, like the RF design or integration of the module or the schematic design review. And our design services are competitively priced, and our experience means that we can provide a really efficient service. Our engineering team are always happy to discuss any custom requirements for a successful outcome at any time. So we really want you to be successful, and to do that, we provide multiple resources to help customers operate on the Myriota network. Field engineering teams and interface to the engineers, they ensure that your device is certified and operating to a successful standard. Our account managers can pass any local inquiries or opportunities on. Our marketing partner program provides resources to support and to ensure a successful product launch, and we can help to generate exposure through media releases or advertising to then generate more attention and exposure around maybe the deployments or those example case studies. So in summary, I just want to recap on the network, and then I can show you some of our partners as well, and then talk about some next steps. There are multiple competitive advantages for using a Myriota satellite connectivity option. Our transmitters enable connectivity anywhere on the planet, as I mentioned, and we've got significantly lower power consumption than existing satellite communications options. The satellites in our network provide pole-to-pole coverage and orbit the Earth once every 90 minutes. And each satellite covers a 5,000-kilometer radius. So if you can imagine, if there's one over the top of the Philippines, it will cover the entire radius and the entire area in one satellite pass. And our satellites are always orbiting, so we've always got that global coverage, and we're very transparent about that information and the elevation and quality of the satellite pass. The network is designed for billions of devices without changing the performance, so we can have as many devices as required transmitting to one satellite, and the messages are encrypted, as I mentioned, so very, very secure. These are some of the partners that we operate with today globally. On the right, we've got some investors like Boeing, Singtel, Inquitel, who's an arm of the CIA in the US, and Spire Global. Spire Global is listed on the stock exchange in the US. They've been with us since the early days and an investor that has launched over 150 satellites. So we have a really good partner there that backs up a great network, and we can easily rotate satellites in as required to make sure we've got the really good redundancy and backup if needed. And then some of our more commercial partners, such as GasBot or AgBot, who do gas and tank level monitoring. We've got Elders and Gallagher there. Gallagher's an agriculture device provider that operates globally, but they're based out of, they started in New Zealand, but now they're now a global provider of devices. Taggle, who provides water meters and mainly operate on farms for water utilities. Grundfos, who's the largest pump manufacturer and provider globally. Intertech, who provide a modem that can have any sensor plugged in. YPF is based in South America, that is part of the government there, and extremely large oil and gas company that we have many deployments with to monitor gas tank levels and return that through a couple of messages a day. And many different government defense partners as well. As I mentioned, we're building out the Internet of Military Things. So there's really secure data requirements around that, and we have our engineering team operating on that quite closely. So I'll just pass over to Ramesh to talk about some next steps between Foundation, ABCD Foundation, sorry, and Myriota, and then we can see how we can progress forward and work together on some applications within the Philippines and in the ag sector. Ramesh, do you want to cover this?
Oh, yeah, sure. So we believe that there are some immediate and key opportunities that both of us can work together. Maybe identify a specific segment within the agro or the marine industry and look at how we can deploy some of our services. Maybe one other way is that we could have a couple of these developer starter kits shared out, and you and your technical team or your support team can get to understand how this works. And if you can identify areas where we can conduct a few proof of concept, we've already been quite successful in doing these in rest of the world. We're already operational in well over 40 countries. And as Tom ran through, there's a very diverse areas where we can come in. We don't need internet, we don't need power. It's all out there. So we, in that sense, very well positioned to be deployed anywhere on earth or land or sea or wherever it is. We would like to take this conversation forward with the team and then look if we can work with your Department of Agriculture and also go through the required support for completing the services. And thank you once again, and back to you, Tom.
Thanks, Ramesh. So that's the end of the presentation. Happy to help out with any other questions from here and continue on from that midway point where we recap some of the information. Our contact details are on the slide, so please feel free to get in touch. There's a support website that's at support.myriota.com. On our main website at myriota.com, there's a really good graphic that shows how the network operates and how we're returning data from the ground through to our satellite network. And more than happy to help out with more custom information that would suit any requirements and jump on another meeting to recap on what we've discussed.
All right, so thank you very much. First, let's give our warm gratitude to both Tom and to Ramesh for a very comprehensive and practical presentation showing the different case studies that they have. Okay, so just as an aside, this is a sidebar, Tom and Ramesh. So this part will be edited out, just so that you're aware, and as I've already explained in our invitation letter, the first hour for the session is what we upload online. So we upload that online for free for our entire audience to view. So I will be saying a few things to end this first hour. I'll give out the certificate. I'll show you a certificate of appreciation. I'll ask for a group photo, and then I'll bring in the next session that we're going to have 2 weeks later. And then I will say goodbye to anybody who will be watching online. And then we'll continue on to our Q&A, which is the informal session, and that's only available for the participants in this session right now. So
Okay.
I will be saying goodbye. I will be saying thank you for joining us and all these things. But please don't go. Sometimes there's a little confusion there with our speakers or with some members of our audience. So this is just to make sure that we're clear on what's going to happen. But this part that I'm talking, where I'm talking right now, will be edited out of that. Yeah. So we're good with that? That's clear? Okay.
Yep.
No problem. Thanks.
So once again, thank you very much to our speakers, Tom and Ramesh. And right now it's already, well, here in the Philippines, it's 11:30. That should be 9 a.m. for Ramesh and 1:30 for Tom. But that ends our formal session for this morning. And if you are joining us 2 weeks later through our social media uploads online, thank you very much for joining us. But unfortunately, this is the extent of what you can get for free. So first of all, I'd like to present our certificate of appreciation to our speaker for this morning, Tom Boot and Ramesh. So the Agribusiness and Countryside Development Foundation Incorporated, with in partnership with the Management Association of the Philippines, together with all our members, our special partner institutions, senior special partner institutions, corporate members, and individual members, all of us present this certificate of appreciation to Ramesh Nagasamudram and Tom Boot of Myriota for their invaluable support in the advocacy and promotion of agribusiness and countryside development, and for their commendable and unselfish services rendered to this foundation as our resource speakers for our 13th weekly online meeting of 2024, given this 14th day of May in Makati City, Philippines, signed Ernesto Ordonez as our chairman and myself as our president. And now may I invite everyone to please turn on your cameras. Let's go to gallery view. Please turn on your cameras. Give us your biggest smiles for a group photo. Jazz, our friends from BF Industries, Daniel Torres, Zumanti Group, please. Big smiles, everyone. Bernie? All right, Vivian, you can count us in.
All right po, sir. We only have one page po. Smile on 3, 1, 2, 3. Thank you po.
Okay. And our session, which will be our next session, which will be on the 28th, May 28th, 2024, is also an exciting one because it will be about a blueprint for corporate social responsibility. If we can just flash that on screen. So we're very, very pleased to have the country lead for corporate responsibility and sustainable development for the Philippines and Vietnam of Cargill. She will be Jennifer Sabianan. She'll be talking about Cargill's corporate responsibility programs, creating sustained shared value. Jennifer has been working in community development as a form of corporate social responsibility for Cargill, and it is very much in line with our goals for rural development here in the Philippines as well. So we're very happy that Jennifer and Cargill have agreed to join us for our session on the 28th. And for those of us here in the foundation who are working on CSR programs or are involved in nonprofit or non-government activities involving CSR programs, I think this would be a great session for everyone. So we hope to see you on the 28th for this session. That will be at 8 a.m. Philippine time. I'm sorry, Ramesh, that will be 5:30 for you in the morning. If you want to join, I'm really sorry, but Tom, maybe you want to come and take a look as well. Anyway, so again, unfortunately, if you are joining us 2 weeks later through our social media uploads, this is the extent of what you can get for free. And we're really happy that you're able to join us this morning. If this session has brought you any value at all, please leave a comment down below. Maybe you're also working in telecommunications or satellite telecommunications, or you're working in other ICT applications for this in agriculture or in the other verticals that Tom and Ramesh have mentioned, we'd really love to hear from you. Leave a comment. Let us know what you do, or if you have questions for our speakers, leave them below. We also have our emails in the description. You can email us at hello@abcdf.org.ph, and we'd be very happy to pass you on to our speakers for this session. But again, unfortunately, this is the extent of what you can get for free. If you do want to gain more, perhaps you'd like to join us for our sessions and actually get to join us for our informal sessions where you can talk directly to our speakers or gain access to our wide network of agribusiness and countryside development organizations here in the Philippines. Consider joining us as a member. We are dependent on your generosity and support, and the generosity and support of all of our members and donors here in the Philippines and abroad. But again, this has been the Agribusiness and Countryside Development Foundation in partnership with the Management Association of the Philippines. I am your president, and we're very thankful to see you today, and we hope you can join us in our next session. Have a good day, and see you again next time. Bye-bye.